Okay, so for absolute dependent motion, actually the step is quite straightforward. So we're going to look at a pulley system where when you pull something, a pulley will move up, mass will move up or move down depending on the motion. So we start with a simple case first. So you're given one pulley system with pulling two objects A and B, and what you start to look at is a bit different from the previous one, is that you'll be seeing data in a question. With this kind of question come up, and you see pulley, be careful on the data position. How you identify data's positive direction? The dot and the arrow. The arrow show you the positive direction that you should use in your calculation. Same with the B. For B, we start with this datum. SB is moving down positive. Okay, now be careful on the datum direction given in the question when we solve this kind of question. Don't be confused with the previous one. Go up positive, go down positive. Always referring to the datum given in the question. And every time you see this one, you know this one is fall under 1.7 kind of solution. Okay, so this question you do simple logic. If you pull A, what happens to B? B will move up, right? Will move up. If you let go of not let go, but you pull B, A will move up. Okay. Now before we move forward, just now we mentioned about data. When you increase SA or you move A down, what happens to B? B will move up, but the direction is negative. SB positive go down. So your SB will become negative value. It's a simple logic one. You solve this question, you look at the question, you imagine what happens if you pull or you let go. Right. So all this you read. Important is where is the coordinate system, where positive, where negative. Okay. And previously, we learned about position, we learned about velocity, we learned about acceleration. So, there are things changed to this black line here. The total length doesn't change. SA will change. SB will change, but CD will not change. Okay. I mean, if you differentiate towards time. So SA will change. When SA changes, it becomes velocity. When you differentiate one more time, it becomes acceleration of A. Same with SB. But you differentiate the length of CD, you always get 0 because this section doesn't change. And the total length also doesn't change. Agree? All right. So the calculation to calculate, first step always, when you see pulley, always go for total length first. So calculate the total length. Okay, and this is a simple pulley. Later you will see 2 pulley, 3 pulley system. Step always the same. You find the total length of the rope. Okay, so in this case, SA plus L of CD plus SB. Then we take time differential to convert, because we want to find the relationship between A and B. We will always look, continue with the total length. We put in a dot on the equation, means we can't differentiate the whole equation. This one, we differentiate total length, what do you get? You get total length, we differentiate with time. 0, because total length doesn't change. This one becomes VA. LCD doesn't change, you get 0. SB, you differentiate, you get VE. You rearrange, you get the relationship between A and B. Okay, why? Okay, this one I explained from here. You differentiate all the equation here with time. You get 0 on this side. LCD 0, you rearrange, you get this. This is the equation that we're looking for when pooling system come up in the question. Right, this is what we want. Then you rearrange. You can rearrange either BB or VA on one side. If you pull this one, you will notice that velocity of A and velocity of B always opposite of each other. Like the simple logic. If you pull this one will move up. And so on. Important is this one. Then you rearrange this one to solve simultaneous equation later. Okay. Right? So this is when you do engineering degree, we always prove our expectation or our hypothesis with equation. Right? So this is all how we design the question also. We have section A, B, C. A always draw something. B you calculate. C always ask you to conclude some of the mention about. Okay, so same, you differentiate velocity one more time, you get acceleration. Okay, now start from these slides. Every time you see pooling system, first step, you calculate total length. Second, you differentiate the total length equation with time. Differentiate one more time. Intention is to get acceleration. So you always have position equation, velocity equation, acceleration equation. Once you have this one, you can solve all that. This one is upgrade a little bit from the previous one. Still the same concept. You have 3 pulleys here. Again, when you look at the diagram, look at the datum. Where is positive? Where is negative? For example, SB positive go down. SB means referring to here, this pulley or this object same because it's at the same because we mount to the same thing. Okay. So SB positive go down, SA positive going to the right. H constant. Okay. Now, if the first step always found and the red color means those constant doesn't change. It doesn't change with time, so you don't need to include in your calculation. You can include that, but when you differentiate with time, you always get. So first, total length. How to find total length? Total length equal to. You can either start from the left or the right. I always start from the left. So equal to SB plus SB plus H plus SA. Okay. So your equation, first you always start with, this is what I mentioned just now. You remember on the where is positive on the statement. So total length, you have 2 SB, H and SA equal to the total length. Okay, so you do the same differentiation just now. We differentiate the first yellow equation here with time. This one has become velocity. H constant is a constant, so you get 0. SA position differentiated with time, you get velocity. Total length doesn't change, so 0. You rearrange, you get this equation. Means that what does the equation tell you? If you pull A, B will move double speed of A, but different direction. That's if you try to pull this one, what will happen to B? B will move up, right? B will move up, but yeah, normally Y and X we assume go up positive, but Y, when you do the derivation, Y negative because of the datum. Datum go down positive, but object B, when you pull A, object B move up. Yeah. Let's say with the acceleration. Acceleration follow the velocity. Once you do the total length, you differentiate velocity and acceleration, you solve for all the unknown. we solve for linear equations simultaneously. Right? The rest is mathematics. Doesn't link with this one. Right? Okay. So now what happens is you change the data. Look at A is what you see just now. B. Can you observe what is different now? Anything different from A and B? B different. Same setup. Datum now change. Will you observe one of the datum change already? Datum B is measuring from bottom rather than the top. B is positive, go up now. So when you pull A in the diagram B, you pull A, B move up, right? So your velocity, A velocity B will be positive because both are moving according to the datum. Okay, let's prove the assumption of the hypothesis. What happens if you change the datum? First one, you already proved already. You get a negative between A. Now we change the datum, we move the datum top to bottom. We do the calculation. Still the same, we find the total length. Now the total length calculation different. You want to find this length. This length no longer SB just now. But to find SB, you need to take the H minus SB to find this length. So this one 2 times plus the H plus the SA. So your equations change a little bit. So always remember, look at the datum first. Then only you start to do the total length time differentiation. You continue to do, rearrange. You get 2 VV and VA. Positive. Just now you get negative. You get positive because the datum change. Okay, you differentiate one more time, same, you get velocity change to acceleration, this one change to acceleration. Okay, this one had mark, this one had mark, this one had mark. Okay, so you should be able to answer why sign is the same, means positive. You should be able to answer. Let's apply what we learned. Just now you've seen single pulley, triple pulley, now it's another triple pulley. Almost the same as, I think, the same as you learned in the statics, but now we learn about the reality. Okay. So, determine the speed of block A. Block A. If the block B have an upward speed of 6 meters per second, you move up, positive moving up. So first, you look at the diagram, identify where is the datum. So the datum A, positive go down. Datum B also move down positive. And then once you identify the datum, use your simple logic, identify the motion. So what happens if you push B up? You push B up, what happened to A? What happened to A? A will move up or move down? Move down. Huh? You push B, this rope will go down, so A will go down. Okay, so at least you identify the early behavior first. Now, then you know that you push B up, right? A will go down. So you push B up means later you will see different motion between A. Means if you push B, A will give you negative sign. You get another one, so you will flip at least you get one of these. Okay, so simple logic first, then you will analyze your final answer. Always the same. The rest you read up, but positive ignorant of speed. Then you find again the red section one is all the doesn't change, the constant value here doesn't change, so we just ignore that. So always find the total length. In this case, you find total length of the rope. SA, I move from the left to right. So SA plus this length, SB plus this length, SB plus this length. So I have 1 SA, 3 SB. Why find total length? Second step, time differentiation, you get velocity. Time differentiate, you get acceleration. Always same. Okay? Always same. Right. Then you can find the relationship between A and B. You either move BB to one side or what. So you can find A. But in this case, when you substitute the value here, careful. So it gives you move upward. So in this case, when you substitute, look at the datum, move up is negative value. Referring to datum is not positive. So the careless mistakes always you forget to refer to data. When you substitute inside, you will get VA is positive value, VB. So if you accidentally you put this one positive, you get negative value for A. Negative value for A means wrong hypothesis only. Okay, be careful on the direction. Referring to different. Nothing complex here. Find the total length, and differentiate get velocity, and differentiate get acceleration, substitution. Then predict the motion. Okay. Next example, I think you can do the same. Next example is a three pulley. And determine the speed of A if B has upward speed 6 meters per second. Still the same, but we change the difference of it. So first, you look at the diagram, identify the datum first. Where is positive, where is negative. So A, datum move down positive. C move down positive. B move down positive. Okay, once you identify that one, and then you will see all those red color, all those constant length one you don't need to consider. Then first step, total length. How you find total length? I move from left to right. This one SA plus this length SC, then this length SC. This case is not a single line. You have two lines inside this system. Because this first rope here do not connect to this rope. So you need to have two total length equations. Okay, be careful, look carefully, don't assume that all question is single rope. If you look at the question, this is a single rope, and then end here. Then continue with the second total length equation, which is SB plus this short length here. How do you find this short length here? SB minus SC. Yeah, this length. So again, referring to how many rope you have, or how many systems you have. In this one, you have two systems. One is on the left, one is on the right. So later, the same steps, find the total length. Find the total length. I put in the first length first. First length SA plus 2 SC. First length. Then second length. Get this one. So you have three unknown here. You have A, you have C, you have B. You have A, B, C. Two equations cannot solve. Right? You have three unknown, you need at least three equations. But now you have only two. Okay, how do you solve? You solve by substitution or simultaneous equation. You find one that you find SC equal to something, then you substitute in one of it. Okay, this is how you solve it now. You have two equations, but three unknown. How you solve three unknown? You find the relationship C either in A or B. Then you substitute inside or on the top one. Then you rearrange back to solve for the simultaneous equation. Yeah, from this step onwards, mathematics. We differentiate the first row. Total length always 0, doesn't change. Sa become velocity, Sa become velocity, you get this equation. This one will tell you the relationship between A and C. So when you come to section C question, always ask you the behavior. For example, you look at this equation. If you move A, if you move A at maybe 10 meters per second, this one will be 2 meters per second. It will be double. For example, but opposite double. So the second equation here, you will reach this one. So rope number 2, you differentiate L2, you get 0. SB become velocity. This one is 2. This one is 2 SB minus C. You get this one. So you're actually solving simultaneous equation. Or you eliminate this one. 2 VB equal to VC. Substitute inside here. You get VA equal to 2 VB. Because VC equal to 2 VB. Then you solve for that. You get the new equation 0 equal to VA plus 4 VB. Then you know that VB is 6 move up. But remember, the datum show you where is V positive, go down positive, but your acceleration go up. Remember, the velocity is negative, not positive. Okay, remember on the direction of your velocity referring to the. Okay, mistakes sometimes will be here. You know how to do, but you forget the direction of it. You get positive, VA is positive 24 meters per second. What does it mean? You get positive, you refer to datum, datum goes down positive. So object A will move up with the speed of 24 meters per second. Again, what you see here, V, velocity, position, acceleration, they are all vector now. All vector. Vector has magnitude and direction. Okay, so far I think it's good, right? In complex, now we change pulley system into application. Single pulley, but add it a little bit with the angle. So a man here is trying to lift this safe kit here or box or something by walking to the right at a constant velocity of 0.5 meters per second. Determine the velocity or acceleration of this object. When it reaches at a certain location, means also freeze the time at elevation of 10 meters per second in this location. The rope is 30 meters long. The total length of the rope is given. Pass over a small pulley at D. So in this case, you see there's no datum. Yeah, there is a datum given there actually. It is your X and Y. The datum is given with a dot arrow. It's a datum. So move to the left, move to the right, positive. Going up is positive. And to solve this question, remind yourself that you are dealing with vector. Vector have direction and so when you deal with vector, there are lots of ways to deal with it. So this is my solution. You give a coordinate system, right? There's a bit now. The first one, you build a rope. So total length is CD here plus this length. Then you start to find what is CD, what is DA by Pythagorean theorem or triangular theorem. DA, this one, you have the total height of this one. There's a right angle triangular here. So you want to find this one, you square this one, plus square this one, square root, you get length of this one. So what you see on the screen here. Another one is the length of CD. Length of CD always takes 15 minus 1. If there's a change of parameter here, which is a 1. So there are two equations that we derive from the diagram. Okay. So this is the difference between static and dynamics. Dynamics will give you a lot of unknown equations. We need to see, okay, how do I materialize it to the term that I understand. So once you have this one, you substitute back to the total length. You have one equation which is linked to your y and x. Right? You substitute this one inside here. Length is given, so 30 on the left hand side. Then this one, we have x and y. You rearrange, you get 1 equal to something. Okay, so it's a long equation. At the end, you get this one, y equal to something. Okay. Then you can't differentiate. You need to use chain rules. Okay, you will use a lot of time in chain rules. It's available in Canvas Appendix B and Appendix C. Where can I read now? So you know that the speed of the shape here is actually dy dt. It's a change of y to find the s velocity, vertical velocity. Right? But in this equation, you don't have t. You only have y and x. So you need to use the chain rules. What I mean by chain rules? This is the chain rules. You need to split the dy dt into dy dx multiplied by dx dt. So you can cancel dx here. Actually, you add the dx on the top and bottom of the fraction here. Okay, you always apply. You'll use these chain rules many times in this module. Right? So especially when it comes to cash, you will start at here. Then you need to find velocity. So you need to find. You will use a lot of time at this equation. So you break this equation dy dt into dy dx dt. You can do this one, right? The velocity of A is your dx dt, which is this one. It's given in the question directly. Dx dt actually is 0.1 meter per second. You can do dy dx like this one. A bit complex, but you can do. It's a differentiation equation. So I will skip all the derivation. So you go back to your mathematics and from here to here. Okay, this one, the bracket one is dy dx. You do the differentiation. This one becomes okay. Then dot dx dt. So dx dt actually is your dA. Then you rearrange again. You simplify, cancel here and there. You get this one. So you get the relationship between the shape and the A. But A you know already 0.1. Right? So at y equal to 10, the question asks you to look at the situation at y equal to 10. So y equal to 10, this is the equation that is used. Y equal to 10, you can find your x, but x is positive. When you have a square root answer, your root will always have positive root and negative root, or positive answer, negative answer. This is the maximum already. When you get your x negative, you go inside the wall. It doesn't make sense. So you only take the positive x. Right? So you at the end you find your x, your location at the time of when you reach 10 meter. Your person here is at a distance of 10 meter. Oh, sorry, 20 meter. You substitute your x inside the equation because your safe velocity still have one constant x. So you substitute back here, and PA is known. So substitution, you get the answer. Yes. Okay. So this question normally in the final exam question kind of standard. It combines your understanding in pooling and also the velocity definition. Okay. So this is how you do some. Okay. The challenging part is the part you try to break this one into what you learn in the course. Okay. So when you see this kind of question, you always ask you to link between y and x, and then try to link back to when you see a shape. Normally there's a few shapes only. Right angle triangular is a normal one. So when you see right angle triangular, always recall back that you can find the relationship between the side of the triangle. Then you start to write, and then you start to see the relationship between the missing part. Okay, then acceleration still says we ask you to find velocity and acceleration. Acceleration is, we have two definitions. One is velocity time differential with time, or position double differentiation of position. So you can use either one. We already have your V equation or Y equation. It depends which one you want to go. You still get the same answer, right? So at the end, you'll get your acceleration of the same is this way. This one, time differential, this one. Again, this one is when you time differential, this one again, you need to use chain rules. You need to do chain rules. Your homework is actually it will take you 10 minutes to give up. Actually, inside my side. Pretty soon. Go home, read this fast. It's a lengthy, but I do it for you already. So go home and read. Go home and revise. Important is not the numbers. Important is how you do chain rules. How you do chain rules that involve with this one, involve with 1 over square root 1. This one you can forget, but try to observe how you solve differentiation that you learn in your mathematics 2 or 1 to find the final answer. Okay, I'll give you the sample answer here and there. Okay, so you substitute, you get the answer. Positive values moving upward. Thus, positive go up. When you get positive, it means you refer to datum and then you predict the. Okay. We have a short break, or we can continue. Yeah, okay, 10 minutes break. Okay.